I'm going to present our problem, our solution to the problem balancing pebble, which states stones which are taken by the wind on the ice of Baikal Lake can be found at the same time staying on a thin stand, which we'll show now, reproduce and explain the stand phenomenon, and estimate the curve of the stand depending on the important parameters. Okay, so this is the picture with the problem, and this is ice, and it stands on this stand. So how did this happen? How did this come to this? So our hypothesis is in a few steps. First, the pebble had settled somewhere on a flat ice. So the ice was completely flat and it stopped somewhere. Ice slowly sublimates away everywhere except the point of contact with the pebble, creating the stand. So where the pebble is in contact with the ice, there is no contact with the air and it cannot sublimate away. Third, perturbation in wind flow around the pebble is affecting sublimation rate around the ice, thus creating the shape that we see on the picture. So, in conclusion, in our hypothesis, wind is the critical factor for this phenomenon. So, ice was here, and this part sublimated away. Here it sublimated a bit more, and here it doesn't sublimate. Okay, so that's our model. So to calculate something, we must know how does wind affect sublimation. So we found two effects of wind. First one, which we will call dynamic sublimation, is carrying water vapor away from the ice surface, thus increasing the rate of sublimation. So if the wind blows, the water vapor above ice goes away and the partial pressure of water is decreased. The other effect is increase of dynamic pressure because of wind, decrease in static pressure above ice surface, and we know that static pressure limits the diffusion rate of water vapor. So more wind equals more sublimation. For the first part, we found a model that is the simple model is written here, where S is sublimation rate and depends on temperature, saturation, pressure, vapor pressure, molar mass, gas constant, and mass transfer coefficient. This mass transfer coefficient is a property of the surrounding air. It doesn't depend on what is sublimating. It depends only on surrounding air. It is how fast can the water vapor get away from the point where it originated. Okay, so for that we found an empirical estimate of Stever and McKay that calculated that it is 0.00882 times wind speed, and this is measured for evaporation of water from swimming pools. But as I stated, it can be applied also here. For static sublimation model, we didn't find in literature some model we know all parameters, so we tried to measure it by ourselves. What we did is this is our simple mind experiment for how we expect the function with pressure to be. So this is ice surface. It first releases some gas molecules, and that dashed lines are mean free distance in air. Mean free distance in air. So they release some water vapors, and some of them are contained by outer pressure, while others go away. Some more are contained again, and some more are contained again. So with higher pressure, this distance is shorter, and the sublimation outside of this box is less and less. So we measured that. This is we measured the evaporation of water in dependence with outside pressure, and we have silica gel to keep the water vapor pressure at a known constant value. And we found out how does the sublimation affect of the outside pressure. What we concluded from this graph is that the difference of pressures that we deal with in our problem are not relevant for sublimation, for differences in sublimation, because as we can see, difference in pressure of about 10 Pascal, which is what we deal with, doesn't change sublimation rate much. So this part we will neglect. So what we did next, when we have our theory model, we did wind simulation. First, this is our first perturbation, and we put flat ice and rock modeled as an ellipsoid. Wind speed was 3 meters per second. This is pressure. This is temperature. This is relative humidity, which are data we obtained from meteorological data. So this is the first iteration. We see that this is the wind speed. We see that it's lower here, higher here, and we see this part here, which also higher wind speed, and this is the pressure simulation. So we calculated wind speed on each point here. This is the same picture but from above. We calculated average wind speed at radius r from the distance from the center, and average average wind speed on radius r at this from center. Why did we do that? We approximated that the wind blows from all directions, not all directions, but it changes directions often and blows from every direction uniformly. And we can see that there are points here on the real wind map of Baikal Lake where this is really the case. Okay, this results delta how much the ice is lowered after first iteration, and now we put that surface in and found the pressure again. We found the pressure again, plotted it again, and put delta H2 in second iteration. And after 5 iterations, we got this shape from, yes, these also simulations were done in SolidWorks. So this is our shape after 5 simulations of iterative, of these iterations. And this is the curve that we get from fitting on our data. It is polynomial because we couldn't find other fit that could explain it. And we see this part, which we haven't seen really on the original picture, but we found another picture on the internet that really confirms that this part can exist, and it's fairly similar. So necessary conditions for formation: first, flow must be fully developed because it's necessary to have a gradient of speed, to have the wind shear between ice level and depends on height. You see here the wind speed is low and it goes up as it goes higher. That is necessary because the high wind speed gets in contact with this rock, which perturbates it, and that makes and then it goes down there. And for that fully developed flow, we must have flat and isothermal ice, low temperature with why? Because of viscosity, which reduces entrance length, and we must have wind from all directions if we are to obtain symmetric solution, which we see in the picture. So some observations we got: flatter base results in thicker stand, higher wind speed results in greater difference between lower surface and surface, and observations, improvements of experimentally test in wind chamber with dry ice. The challenge is that flow must be fully developed before colliding with the pebble. Thank you for your attention.
from the Italian team, and this is our review of this report. So first of all, the highlights. High sublimates except of the under the pebble in contact with the pebble. It's good. It's correct. Then when you increase the sublimation rate, you notice having this phenomenon. It's correct. So the pressure and humidity are important to help with the phenomenon. And then the sublimation of the phenomenon is not so intuitive to understand that could be the sublimation of the phenomenon. So it's got a good idea. The sublimation, the temperature can help the reaction, but it's not so easy to think about that. So the pro of your presentation, you have to do a good work, a good practical work. You have to do a good simulation. You explain very well the physical idea behind this phenomenon, and you find a good theoretical model, even if it's a simulation, but the idea behind is good. You have a good simulation prediction. It's similar. It looks similar at first seeing. Looks similar the stand. So good. And this is what you have done a great work on it. And the concept, what for me has been done not so good in your presentation. What's the fault of your presentation? For me, is the phenomenon are not reproduced. We can understand that it's difficult. Maybe we can understand if there are some way to reproduce the phenomenon in some easy way. And then few measurements. We didn't see any measurement of your work. You have suggested a model, you suggest a simulation with wind, yes. You have reported some parameter about that region, but you don't talk about the unicity of this phenomenon in that region. Because happened just like that, just like that, just like that. And so you choose sublimation, but why? A lot of phenomena can create this. Of course, if you go in completely another point of the planet, you can see similar phenomenon, but caused by different conditions, different phenomena. Even with sand, you can see this stand. With sand, a pebble over the sand can form a stand similar. It's different phenomenon, but even with other phase transition like melting of the ice. A similar stand can be created. So why you have thought about the sublimation? No estimation of the curve of the stand. You just simulated. Direct estimation. For example, if you go over the first iteration, how does that image change? For example, it's more regular, assume different shape, something like that. Then, the question that I ask you are, how much is the low temperature relevant? Must be just below the 0 in Celsius, or it must be very low? Then, can it happen just in Baikal, on the Baikal Lake? What is the time necessary for this phenomenon? How much time need the lake to form the environment to form the stand? And you may, so because you don't have proposed any experiment, you have some experiment to suggest. We can go on with the conversation, with the time, and so I don't know. Sorry, we can go on with the time. So,
first of all, thank you. These are all excellent questions and great questions, and I would like to answer them. And I did some of them, but I hadn't really the time. So can you go to the slide back, please,
yeah,
so I can answer some of these questions. Phenomenon not reproduced. Well, okay, it is reproduced with the simulation. But experiments suggest, I did suggest one experiment and I did try one. I suggested that we tried it in a wind chamber.
Wind chamber?
Yes, but with dry ice instead of
Yeah.
regular ice, and I tried it with dry ice and with a nozzle that blows pressurized air, like a fan.
Okay, okay. Yes.
But it was a nozzle.
With more directed, more fast.
Yes, and it didn't work because you need. It is so important to have the flow that has gradient. To have wind speed gradient from the ice level up. That is important because when we tried it with the nozzle, it always sublimated the most. It's like if we from here blow, this part sublimates more and this less, and the effect around the stone is not even it's not visible.
Yeah.
You would have to be much further away and have a long patch of dry ice before you could get the effect on the pebble to be visible. And that is exactly why this can happen on Baikal Lake, because it has huge patches of very flat ice. Baikal Lake is famous for its clear flat ice, and that is necessary. I couldn't reproduce that.
How much velocity of the wind you think do you need?
Yes,
it can happen just
okay,
3 kilometers
yes,
per second.
That is the average velocity, wind velocity at Baikal Lake in January.
In January.
Yes, and
why
temperature.
January?
Because in the pictures you cannot see any moisture.
I can't
Oh.
see a computer.
No, it's okay. You cannot see any moisture on the ice. So and it's daylight. So we assume that the temperature isn't high enough for ice to melt. And in fact, the average temperature in January on Baikal Lake is minus 10 degrees Celsius.
Nice.
Minus 10.
10.
Yes. Minus 10 degrees.
I'm disappointed, sorry. The Baikal Lake is, first of all, the Baikal Lake is too big.
Yeah, but this
to define
average temperature.
use just one temperature to say the minimum temperature on the Baikal Lake to say that
around
this is
minus 10 degrees average temperature.
Okay.
Yes. And that's why I didn't use melting of water ice because it doesn't melt. Minus 10.
I think so. It doesn't melt over there. Yeah. I think that don't melt the ice over the Baikal Lake, but I not surely know this thing. Could happen. I don't think so. But could happen. You could try it. Have you tried if?
But melting doesn't. I tried. I thought about other things that could be important. Like I've thought about the effects of sun, heating, and day and night changes.
Okay.
But
you haven't talked about the effect of sun.
Of course, but none of that could explain the radial symmetry of the problem, because sun at the winter in Baikal Lake is fairly low. Its curvature is low on the sky.
Do you think that the shadow of the pebble is important?
I think it's not, because if it were important, it would be asymmetric, and it's symmetric.
1 minute left.
Okay.
The solution is symmetric, so I
The
think
solution is not always symmetric.
it's pretty symmetric.
In the second image,
Yes, but I think because wind there. Okay, so you cannot get a symmetric solution with something that can produce only asymmetrical solutions.
Yeah,
But
okay.
you can go other way around. You can get asymmetric solution with my wind.
But if you have the sun that arrives by an azimuth, low azimuth, for example, and you have the energy from the sun that may help the sublimation. So if you have a shadow behind the pebble, maybe there the sublimation occurs slower.
Maybe.
The standard could be different.
Maybe. But
Creating
it wouldn't be symmetric. But
it's not always symmetric.
But it is in one point, so you can. If there is one instant where it is symmetric, then this cannot be a solution.
Thank you. And now we have to go to the question from the review team.
It says that important are gradient of wind speed, and
Yes.
we know that near the body there is no wind speed,
Yes.
and there are gradients. Gradients exist. They exist everywhere. So and You said you couldn't reproduce the phenomenon due to you have no gradient, and gradients exist everywhere.
Yeah, I had the gradient, but it's important to have the very close wind speed in close to the surface.
How close? What is the length, height of this layer?
Because if you have a turbulent flow, if you have undeveloped flow, you have perturbation around. So I need the rock perturbates the fast flowing wind in regions where the wind is slow. Wind flow is slow, and that's how we get that fast wind below the stone. But if the flow isn't fully developed, and I tried that, then you would get only slower wind below the slow. You won't get faster.
So important are not gradients but turbulence?
No. I mean,
Okay, we'll discuss it further.
In your model, do you consider that the wind blows from one side to the other? In one
okay,
direction?
so can I say?
Yeah.
I simulated the wind from one direction.
Okay, so the question is why you stand is symmetric and
Of course, yes.
is it really symmetric? Yes or no?
I simulated it from one direction, and I took the average velocity on radius r, mean velocity, because I simulated from one direction. But if the wind blows from every direction, then the mean velocity is important.
So you don't consider the asymmetry due to the direction of wind?
Hello everyone, my name is Olga, I'm from Team Ukraine, and now I'm going to review the problem number 17, balancing pebble. In this problem we were asked to reproduce and explain the stand phenomenon and estimate the curve of the stand depending on important parameters. I want to say that we see in the report explanation of this phenomenon and this theoretical modeling for the curve of the stand. However, we didn't see the reproduction of the phenomenon, and we didn't see how the curve of the stand depends on the important parameters. And start with the overview of the report. Starting with the strong points, the reporter stated his hypothesis about the wind influence, and we agree with this statement. Also, the reporter showed us simplest sublimation rate estimation. And also, the reporter showed that the pressure difference isn't significant, which is also very good. And the reporter made a modeling which shows he obtains a stand in however, we, as I already said, we saw the absence of the reproduction of the phenomenon. Also, we didn't see the modeling equation, and it will be interesting. Also, there wasn't listed the parameters that define curve. We were asked about the statement of the problem, and so minus no slide numeration, it was hard. About the position, the opponent pointed out the absence of reproduction. He claimed the lack of measurements on the 3 point, and brought up the question about why sublimation and load operation, which wasn't in the report. And in the discussion, they discussed the possibility of reproduction. Is it possible or not? And then they discussed the important parameters on the Baikal Lake, which is important, which parameters we cannot obtain in the laboratory to obtain the stand. And they discussed the influence of the sun, which wasn't in the report also, and the relevance of temperature. And I propose you to discuss on discussion the important parameters influence the curve. Maybe you may list it or something. Also, which conditions we need to stand formation. For example, maybe it is some critical temperature, wind speed, illumination of the sides, long parameters, and you use wind 3 meters per second in your modeling as understood by 3 meters, and role of turbulences, and it's time for the discussion. Starting with the first point, how do you think both the reporter and opponent which parameters define the curve of the standard?
Okay, so I didn't state effect of. I don't have the exact dependence of important parameters. I only have what I seen is happening, and I have seen that with greater wind speed, the difference between the lowest point and the lake point increases, and I have an explanation why that is. And I have also seen that if the pebble is flatter at the point of contact with the ice, the curve that the stand that will form will be wider, and I also know why that happens. But the shape of the stone is also important, but I didn't find any systematic way to vary shapes of the stone. You could take any shape of the stone, and I don't see how I would systematically vary it.
Okay, and did you want to comment?
About the important parameters that influence the curve. For me, the wind is the most important parameters that maybe can accelerate the sublimation around the stone in the much. But for me, there is even the effect of the sun, because the sun in that region is not so cloudy in that period, so the precipitation, for example, are very low. And the sun, even if it's in the azimuth, it's a lot for all day. All day long, the sunlight arrives on the lake. So the sun energy, for me, couldn't be transferred. And this energy could be radiated for a bit because the pebble, the pebble increases temperature and can radiate heat around it, in helping to the forming of this curvature, of this hole.
I tried the effects of the sun in both a way of heating the stone more than surrounding ice, and the effect of shade. And I couldn't find any indication that would form this result that we have. And if my opponent has indication that it would form do you have any motivation why the sun would form that shape? I think there isn't one.
I don't think that
we should move to the next question about do you think there are some critical value of temperature, wind speed for obtaining the
to have this phenomenon, temperature should be below 0 degrees centigrade, and the lower it is, the better. Also, the precipitation, like snow, there shouldn't be much snow, and it isn't, because if the snow falls on flat ice, it would make it rigid, and that would ruin everything.
And do you agree?
Yeah, I agree, but there is a limit for the phenomenon to occur. Cannot happen at all temperature below the 0 grades.
What?
The phenomenon of the
what limit?
What limit?
Which temperature is going?
Okay, here I can estimate without for me the temperature. Okay, sorry.
What do you think about? Okay, I think it's time for the general discussion. We will move to this point maybe later. And now I ask the reporter team.
You mentioned that sun is important parameter in this whole story, right? Yeah. And before that you said that this phenomenon is observed in deserts with sand. How does that make sense?
No. Okay, not that phenomenon. In there you can see the effect of the wind that formed that shape.
Similar
so
to
it's wind.
Similar to the wind. Yeah, similar shape. Okay, but this can happen not just with the wind. In some places you can see the erosion of the wind that forms similar structure. The phenomenon is different. Okay, but in such region you can even see that you have a little pot, a little hole, because the heat energy radiated by the pebble, for example.
But
it
there
could
is
be
no-
recreated. You can see it. You making an experiment. You can see that if you use something like sun to like a energy source, this starts to form without wind a little pot. I don't know the right word. A little stand or little. You need much more time to create.
But there is no water in here.
No, that is ice. I'm talking about water. Water because it is more easy to see. But even there happen because if I have the energy of the sun, increase the time to form the stem, and enlarge the hole because the energy of the sun, for example, radiated not like where the window hit stone. For example, if the pebble, the sun have a lower pressure here and excavate here.
Just a minute. If it was the sun, I would accept
Not
the
only the
shading.
sun, not
Okay, so
only.
sorry,
Okay,
sorry.
okay.
I'm sorry to
Okay.
interrupt. I think we should give word to the opponent.
I would like to ask if you can give a rough estimate of the time that is
Yes.
needed to
Great
this
question.
phenomenon to occur.
Great question.
Hours, days.
Great question and very difficult question because when the wind it flows over Baikal Lake, it picks up saturation as it goes. So at points when it gets to this stone, we are talking about very high saturation levels. I would say around 90 to 99%. And the problem is that I cannot give I can give a very rough estimate because the difference between 1% difference with 100 and 10% is 10 times. So I would say the window is between 1 week or 1 month. That is my calculation. Between 90 and 99% saturation. Around.
Okay, thank you. And reviewer team.
I have a following question. If we were to consider how does the stone harden the ice below, and we consider your simulation that there is a small point in which the stone is standing, how important it will be for the airflows around the stand, and how does the shape will change if we consider the hardening?
So in the first iteration, we see relatively mediocre influence of the stone on this area. It's not so prominent as it is in this. It goes more inside, and the wind speed here is greater. So in my iteration, I saw that in my first iteration there was a small difference between the lowest point and the lake point, and in iterations to come, this difference increased.
What I want to ask, does the consideration of this hardening determine the diameter of the stand near the stone? So the stone hardens by its pressure. Diameter.
No, that effect is negligible.
Okay.
Okay, and opponent.
I want to ask you, with the wind, with your simulation, the hole, how much could be the deep of the hole?
Yes.
If your wind can...
This is 4 centimeters, and the hole was 2 centimeters.
The hole was 2 centimeters?
Yes.
And can't go on? Stop.
Yes, it can.
Stop to develop. Why?
No,
it can go on, okay. It can
yes.
Go on. Why? So we can have an infinity...
No, because the winter is not infinitely long.
Oh, okay. I think I think the time is over, and we need to move to concluding remark.
I think that we managed to get an intuitive explanation for hard to explain phenomenon, and I think that is an accomplishment by itself. We reproduced the curve, and we discussed how it depends on parameters. So all in all, I would say we managed to make a breakthrough in this problem. Thank you.